Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be solving real-world problems involving two-step inequalities. Let's start with an example. Kaylee is putting money into a savings bank she keeps at home in order to save up for a new camera. She starts to put $20 per week into a bank account, which started with $60 already in it. She wants to save at least $400. So the first question asks us, will 12 weeks be enough time to meet her goal of having at least $400? Well, the question told us that Kaylee started with $60 in it, and then she's going to save $20 per week. So if she saves for 12 weeks, would she have at least $400? So let's evaluate this here. 2 times 12 is 24, so 20 times 12 is 240. If I add those two together, that would give her 300. So 12 weeks will not be enough time. Okay. Question 2. What is the smallest amount that Kaylee wants to save? So the smallest amount she wants to save is 400 because it said she wants to have at least 400. I'm sure she'd be happy with more than 400, but 400 is the smallest amount that she wants to save. So if n represents the number of weeks Kaylee has been saving, write an inequality to describe the situation. So Kaylee started with 60, and then she's going to add $20 per week. It said let n represent the number of weeks. And then she wants to have at least $400. So that's $400 or more. So our inequality that we'll use will be greater than or equal to 400. All right. Now, to solve this inequality, we're going to solve it just like normal. And we'll determine how many weeks she needs to save to get at least $400. So we'll subtract 60 from both sides. The 60s will zero out. So 20n is greater than or equal to 340. And then I'll divide both sides by 20. So n must be greater than or equal to 340 divided by 20 would be 17. So she must save for at least 17 weeks to meet her goal. So in word problems, phrases like at least indicate that an inequality should be used. Another common inequality phrase is at most. So let's look at an example that uses the phrase at most. In example 2, it says a truck can hold at most 750 pounds. It is loaded with a desk that weighs 125 pounds and boxes of books that weigh 10 pounds each. Could the truck hold 70 boxes of books along with the 125-pound desk? Well, let's see. We have the 125-pound desk, plus we're going to add 70 books that weigh 10 pounds each. So that would be 125 plus 700, and that would be 825 pounds. Now, what was the largest number of pounds that could be loaded on the truck? Well, that was 750 pounds. So no, the truck will not hold the desk and 70 boxes of books. All right. In our next problem, it says, let B represent the number of boxes loaded. Write and solve an inequality that models all possible values of B, and then solve the inequality. So we know the truck has 125 pounds, plus we're going to load boxes that weigh 10 pounds each. So 10 times the number of boxes, and that's going to be, that value, 125 plus 10b, must be smaller than or equal to 750 pounds. So we're going to use the inequality less than or equal to. So whenever you see the at most, you're going to use the inequality less than or equal to. Now to solve this, we'll subtract 125. So this would zero out, and we would get 10b is less than or equal to 625. Divide both sides by 10, and you get b is less than or equal to. Now remember, when you're dividing by 10, you don't need long division. It just moves your decimal in one place. So this would be 62.5. Okay, so the number of boxes has to be less than or equal to 62.5. So what is the largest whole number of boxes that could be loaded onto the truck? Well, that would have to be 62. We could not go over, we could not use 63 because the inequality told us that the value, the number of books, had to be less than or equal to 62.5. So you would not want to round up here. We're going to go with 62 boxes. All right. In example 3, it says match each phrase with the appropriate inequality and number line. So in the first phrase, it says teenagers need at least, let me highlight that, 9 hours of sleep. And for at least, we use greater than or equal to. So look at your inequalities, and there's only one that has S is greater than or equal to 9. So the inequality would be C. Now the graph, we want a graph, a number line with a filled in circle because this says equal to. So it has to be either F or H. But we want to indicate that the sleep has to be greater than or equal to 9 hours. So hopefully you said number line H. All right, pause the video and try the other two examples on your own. When you're ready to check your answers, press play. All right, welcome back. Mrs. Jones wants to spend at most $9 for a movie. So for at most, we use less than or equal to. So that was inequality A. And that would be graph number line F. All right. Next one, Jason has fewer than 9 sneakers. So that means he has less than 9 sneakers. So that was inequality B and number line G. If you need to correct any of your answers, just press pause and then press play when you're ready to move on. All right, example 4. Jared is designing a rectangular garden whose length is 25 feet. He needs to put fencing all around the exterior of the garden and wants to use less than 80 feet of fencing. Could the garden have a width of 12 feet? Well, we know from the problem that our length is 25, so that means these two sides are 25. What they want to know in this question is could this length could this width and this width be 12? Okay, so let's add that up because the perimeter of a rectangle, we just add up all 4 sides. So 25 plus 25 is 50. 12 plus 12 is 24, and that would be 74. Now, it says that he wants to use less than 80 feet. So is 74 less than 80 feet? Yes. So yes, the width of the garden could be 12 feet. That's a possible solution to this problem. Now, let's let W be the width of the garden. Set up and solve an inequality for all possible values of W. So to find the perimeter of the garden, we're going to add up all four sides. So if this is W, then this side is W, and this side is 25. So I'll say W plus 25 plus W plus the 25, and we want it to be less than 80 feet. Now, if we combine like terms, we can combine the W's together and the 25s together. So that would be 1W plus 1W would be 2W, and 25 plus 25 would be 50. And we want that to be less than 80. So subtract 50. So 2W is less than 30. Divide by 2. And we get that the width of the rectangle must be less than 15 feet. The width of the rectangle must be less than 15 feet. All right. Example 5. An elevator in an apartment building starts 330 feet above the ground. It moves down at a rate of 8 feet per second. We are interested in finding all the times t when the elevator is above 200 feet. Choose the inequality which best represents the situation and solve. Now pause the video and try this problem on your own. What I want you to do first is select which which inequality you think best models this word problem. Once you've chosen the inequality you think best models the word problem, then solve that inequality. When you're done, press play to check your answer. All right, welcome back. I chose inequality D. All right, so to solve that, I have 330 minus 8t is greater than 200. So if I subtract 330, this would zero out, and I'm left with negative 8t is greater than negative 130, and then I divided both sides by negative 8. Now, what you have to remember here is from our previous lesson, when you divide by a negative, you must reverse your symbol. So the greater than is going to become a less than. Now, negative 130 divided by negative 8. A negative divided by a negative is a positive. So I'm just going to see how many times will 8 go into 130. Let's see, 8 goes into 13, 1. 13 minus 8 is 5. Bring down the 0. 8 goes into 56 times. Add another 0. 48. 50 minus 48 is 2. Bring down the 0. 8 goes into 20. 16. No, excuse me. Why did I write 16? 8 goes into 20 2 times. 2 times 8 is 16. Subtract, bring down. 8 goes into 40 5 times. So the time must be less than 16.25 seconds. And that concludes today's lesson, solving word problems involving inequalities.